Hello, Algebra 2 students. Mrs. Myers here. We are going to take a look at more graphing of sine and cosine cycles today. This is lesson 11, day 1, is we're going to be doing translations, okay? Day 2 will still be translations, but of a different nature. So today is going to be vertical translations. Thursday will be lesson 11, day 2, which will be horizontal translations, okay? I think it's going to be best for us to separate those, put those in 2 different days there. We are also going to be revisiting the dilations and the reflection over the x-axis. We're not going to do a reflection over the y-axis. We don't have to worry about doing that. What I've done for the start us off with the notes here, which I would like you to do for your notes, is I've put down what one cycle of each of these looks like with respect to the critical points. It is imperative that you know this, okay? And you have to realize a couple things about this. I thought it was clear. I tried to be clear with the other lesson, but I want to just stress some things now just to make sure, because I've seen what your homework looks like. One is that we're going to be doing it on graph paper. Okay, you have to have graph paper. I did say that before. I gave a reminder to a lot of you that didn't do the homework on graph paper to do it on graph paper. Either print graph paper from the internet somewhere. You can totally do that from tons of different websites, or you have your own graph paper, or you're gonna actually have to take like maybe printer paper or line paper and like grid it out, okay? Because you have to have these critical points be equally spaced, okay? You have to have an equal spacing on your y-axis and on your x-axis for each of your critical points. So for the sine graph, we start at a midline point, we go to a maximum, we go to a midline point, down to a minimum, back to a midline point. Okay, you'll definitely see today what midline points are all about. Okay, notice how each time I was using exactly one box, okay, along the x-axis to go from one critical point to the next critical point. And notice how, because I decided to go up 2 boxes to the max, which for the parent graph is just at 1, notice how I went down 2 boxes for -1 to get to the minimum, okay? Some of you were not accurate at all with this in your graphs, and that is just, you can't not be accurate, okay? So you gotta be more careful. So here we go. We have the cosine cycle, which is max, mid, min, mid, max. Again, notice what I decided to do is just go 1 box at a time, okay, when I went to plot each critical point, and I went 2 boxes up to 1 and 2 boxes down to -1, because that would be the parent graph. And as far as parent graphs is concerned, like, one cycle would go out to 2 pi here and here, if I was just, again, talking about the parent graph, where it would be by pi over 2s, to go through each quadrant. We're doing transformations, so that's going to change, okay? But anyway, again, I really want to stress the importance here of you being equally spaced here with your graphs with respect to these critical points. I could have done 2 boxes out before I plotted this midline point here. I could have spread it out further, but then that minimum would then be 2 more boxes further out. The midline point would then be, again, 2 more boxes further out, and the maximum would still be 2 more boxes further out. You know what I mean? Like, you'd have to keep that spacing going. All right, so we're going to do 2 examples together today, and hopefully this will really clear some things up if you're unsure. So we're going to do y equals 2 sine 4x minus 3, okay? So the first thing I want you to do is list out what the transformations are, and remember, we always do them in the order of DRT, right? So dilations occur when you have multiplication going on, right? You're going to look for multiplication. Reflections occur when you have negation, and translations occur when you have adding and subtracting. Hopefully you remember that. And how you know which way it's going to affect your graph is that whole HIVO deal, okay? So, sorry, I'm just getting more pencil it out here. All right, so anyway, I'm looking at multiplication in 2 effects. I'm looking at timesing by 2 there, and then timesing by the 4 there. Now that timesing by 2 is outside, so that is with respect to the y's. And whenever you're going to dilate with respect to the y's, that multiplier is going to be your scale factor. Do not change that. Again, I knew it was with respect to the y's because it was outside, okay? Outside's vertical. So what happens is we change the amplitude of the graph, okay? So remember, this vertical change right here, okay, when we go from the midline to the max and from the midline down to the minimum, okay, that is what we call the amplitude, and that has to be the same. Okay, that vertical change from mid to max and mid to min, okay, that vertical change is the same. That is, again, called your amplitude. So for the parent graph, it's 1. Okay, so the maximum and minimum values are at 1 and -1, but now this is changing. Okay, so it's going to be 2 instead. Now I'm also looking at the dilation of 1/4 to the x's here. So that is always, that multiplier when it's inside is for the x's, and it always has to be reciprocated to be your scale factor when it comes to the horizontal, okay, when it comes to the inside. So it always has to be reciprocated. Now, I don't have any negations, okay? This is not a negation, okay? This is a subtraction of 3, so that is a translation. Now, we're only going to be doing the vertical translation today, and that's exactly what you should see this as, because this is outside, okay? Outside's vertical. So that's actually going to make the graph go down 3, so I'm going to write it as 0, -3, like that, okay? So anyway, let's get to making a sketch of this. Now for this first problem, what I'm going to ask you to do is I'm going to ask you to graph 2 cycles, okay, as we've done before. So let's get to graphing that first cycle. Okay, if you have a ruler, you could of course use a ruler here. Now I'm going to keep in mind something, okay, when I'm making my graph. I'm going to make my initial graph from just the dilations. Okay, this is going to be my initial sketch, is just doing the dilations. Then if I have a reflection, I'll do a second sketch for that. Then if I have a translation, I'll do that as a third sketch, okay? So I know I have to go up to 2 and down to -2 for my amplitude, and I also have to go down 3. So I'm going to make sure, okay, that I have my y-axis, okay, brought a little bit further down, okay, than I typically would have, so that I can extend it, further down. I can move the graph down, okay? Now, as per the initial graph, okay, I'm going to go up to 2 and down to -2, because that is my amplitude, okay? So I know I'm going to do that. And if you'd like, we can still stick with 1 box per every critical point. So I'm going to eventually, I'm going to do 2 cycles here, right? And every box is going to need to have a scaling. Okay, that's the other thing, is we got to get this all scaled out. So now off to the side here, I'm going to write down some critical information. So first is, what is my period? So when you're horizontally dilating graph, that changes your period. Now your standard period was 2 pi, but I am going to be horizontally compressing it by a scale factor of 1/4. So what I'm going to do is I'm going to multiply that by 1/4. Okay, whatever your horizontal scale factor is, you make sure to multiply that by your period, and that now becomes, so let's see how this reduces down, okay, to pi over 2. Okay, so at the end of my cycle, that's not going to be 2 pi radians anymore. It's going to be pi over 2 radians, okay? So what is that scaling going to be? So I'm going to take this period, I always take what that period is, and divide it by 4, okay? Divide by 4, because there are 1, 2, 3, 4 equal intervals to make up the cycle. Now, to divide pi over 2 by 4, you might want to go pi over 2 times 1/4, and there's pi over 8, okay? So if you want to have every box be a box for a critical point, then you have to scale that by pi over 8. So this is 1 pi over 8, 2 pi over 8. Of course, you can reduce that if you'd like to. 3 pi over 8, 4 pi over 8, and 4 pi over 8 reduces to pi over 2, which makes sense because, see, there's my period, okay? So I start at, this is the sine cycle, so I'm looking here. I start at a midline, okay, that's right there at 0, okay? After pi over 8 radians, see, because I had that compression, I had that horizontal compression scaled down for my period, so now I can see, okay, that after pi over 8 radians, I'm going to get to my maximum, okay? Then another pi over 8 radians later, so at 2 pi over 8, I'm back down to a midline point. Then I'm another pi over 8 radians down to a minimum. Then I'm back up to the midline, okay? So this is what one cycle looks like. So whereas before, see, I didn't actually have to even change, 2 boxes up and 1 box per each like that as far as the graph is concerned, but I had to change the scaling. See, before it was 1 to -1. Well, now I'm vertically stretching that to be 2 to -2. I mean, if I had made these only be 1 box high and now it's 2 boxes high, then you would, see that vertical stretching going on, okay? But here, pi over 2, I didn't really want to have to condense that all the way down, okay? So here's my pi, here would be my pi over 2. This whole cycle, I would have to squeeze it down and have it all fit right in there from 0 to pi over 2. Well, that would be crazy. I mean, to try to make this whole graph, be like accurately sketched out within just one little box. No, so I don't need to do that. I can just still use, 1 box to get from one critical point to the next, but I'm going to change the scaling. See, I'm going to show that it wasn't 2 pi radians to finish the cycle with, every critical point being pi over 2 radians, I'm going to show that it was pi over 2 radians to finish the whole cycle, see? And then it's every pi over 8 radians to go for one critical point to the next. Now, I need a second cycle. You are welcome to go out in the negative x direction for your second cycle, or we could just keep going in the positive x direction, okay? I could just, again, 4 more boxes to get the cycles, okay? So after this midline point, right, where do you think we're going to go next? Okay, well, this midline point that ends the graph is like that midline point that started it, okay, that started the cycle. So I'm going to go up to the maximum, okay, down to the midline, down to the minimum, back to the midline, and that is a second cycle. See how I plotted the points first? You know, plot your points, then all you got to do is connect the dots, okay? Everyone connects the dots all the time. You know that that's fairly easy to do. So, you know, you just, that's what I want you to think about, okay? Don't just like willy-nilly put the graph in there and, you know, not be accurate, okay? Really think about what you're doing. Plot all those critical points first. Now, again, I'm not going to just stop there. This is not even complete as far as the dilations are concerned because I don't have more scaling. Okay? I have to have scaling along the y-axis and the x-axis for every critical point. Okay, so how do I keep going here? Well, I'm going to remember that it's pi over 8 radians for every critical point. See, that's what I did. I took the period, divided it by 4. Now I know there's pi over 8 radians for every critical point. So it was 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So just keep counting. 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. And you're welcome to reduce. Again, that would reduce down to pi over 2, right? That would reduce to pi, and now that would make sense, right? If pi over 2 radians is needed per one cycle, and I want you to do 2 cycles, well then pi radians should finish out that second cycle, okay? All right, so did this, now I gotta do this. Now I gotta move the graph down 3, okay? Now to move the graph down 3, this is where the whole midline comes into play, see? The midline, okay? What's halfway between the min and the max, okay? Right now, that's the x-axis, okay? As per the parent graph, it's the x-axis. But if you move the graph up or down, then you're going to change that midline, okay? We talked about that before with the exponential and logarithmic functions as potentially changing the horizontal asymptote when we move the graph up or down. And then when we move the graph left or right, that changed the vertical asymptote. Well, just think of this as the changing of the horizontal asymptote because we're moving the graph up and down. Although it's not an asymptote, it's the midline. Okay, so I'm going to go right here at -3. And I'm going to just dot it in, okay, because it's not actually part of the graph, it's just going to help me. And I'm going to write midline y equals -3. So now what the graph looks like with respect to the x-axis, that's exactly what it's going to look like with respect to the midline when I'm done, okay? So every point goes down 3. So I'm just going to look, right? See this 0 point right here? That goes down 3 boxes, right? And this is nice, it's easy, 3 boxes, because every box is 1 unit. So this was at +2, so I'm going to go down 3 boxes. Okay, I keep breaking my lead. And that has to now have a scaling here, see? -1. Make sure you put a scaling. So this is down to the midline point. So this is at -2, and if I go down 3 boxes, okay, that's now going to be at -5. So notice I put the scaling there, okay, and then back here. Okay, so that's what the first cycle looks like. Okay, just being moved down, and then I just do the same thing, right? So this goes here, there, there, right? I'm just moving every point 3 units down, okay? So if you want, you can then, you know, erase this graph, kind of scribble it out, right? Label this as, you know, the final graph. You could do this in color if you'd like, make the new graph in color, or you don't even have to do it on the same set of axes. You could redraw a new set of axes next to it, and then that way it's just, you know, the previous graph there, and then now the new graph. All right, so let's do one more practice problem together. And as you could probably guess, let's do this one in terms of cosine. So, and I'm actually going to write the equation a little bit different here for you, just because I want to make sure that you see all the different ways that I could possibly present this to you, okay? So anyway, let's start by jotting down all of our transformations, okay? So dilations always come first. So do we have any multipliers out in front here, okay? I mean, I sort of do because it's a minus sign here, but that's not a number, that's not a 1 there, okay? That's like a 1, so I don't really have any multiplier there. But that 3, okay, that's inside. That's going to tell me that I'm dilating with my x's, okay? That's horizontal. That's with respect to my x's, so make sure you reciprocate, okay, that multiplier there. Okay, next is the reflection. So here's what I'm going to suggest we do. We're going to take this equation, okay, and I'm going to actually rewrite it. So I'm going to rewrite it. See this positive 4 that's up in front? That really could have been in the back. So now instead of 4 minus cosine 3x, I have the negative cosine 3x and then plus 4. Okay, this is actually how I think it's better to see it, but this is how they would very often present it to you. So if you have that constant up front, okay, just put it in back. Okay, if this was a negative 4, then you'd put minus 4 in the back. Okay, but it's a positive 4, so you put a plus 4. So you can again see that there is no dilation vertically that's going to be done to the graph, no changing of the amplitude. That's just going to be 1 and negative 1, okay, because there's like that 1 there. Okay, and then dilation of the 1/3 to the x's. Now this is a negative. See, before just kind of we thought of it as a subtraction. Now we really realize that that's a negation. So that's a reflection, and that's outside. Okay, outside's vertical. Vertical reflection, right, means that it's going to be over the x-axis. Okay, we're not going to do reflections over the y-axis. You don't have to worry about them. And this is now a plus 4, so we can see that the graph is going to go up 4. Okay, so we're going to make our sketch, okay, of our one cycle right now. And actually, we're going to go up 4. So I think I'm going to move my x-axis a little further down just because I want to have enough room to make the graph go up 4. So it's kind of good to think about that ahead of time. And if you can't draw nice straight axes, take a ruler. Okay, get yourself some nice straight axes. So anyway, I'm going to make my first sketch just based on the dilations. Okay, and I only have the one dilation to do, so that's going to be my first sketch. Okay, so just 1 to negative 1. I'm just going to do one box here, okay, because if I do more than one box, then to go up 4 boxes is going to take a lot of boxes, okay, so I'm just going to go one box up to 1, one box down to negative 1, okay, and then 4 boxes out to do the cycle. Again, I could do 2 boxes. Actually, let's do that. Let me just show you how that I could actually do that. I could do 2 boxes out for every critical point. That would be fine. Make the graph a little bit wider here. So that would mean, okay, this is cosine. Okay, cosine starts at a maximum, okay, that I would be right here. Okay, right at 0 radians, be right there at maximum. And then the midline point, okay, so if I want to go 2 boxes to get to the midline point, so see that? 2 boxes there, that's fine. Then what comes after the midline is the minimum. Okay, so I have 2 more boxes. And notice how I'm, 1 box up with the max, so I'm 1 box down to the min, right? And then 2 more boxes to that midline, and again 2 more boxes to the max. Okay, so that's one cosine cycle. So you can do that. You can spread it out as much as you want, vertically, horizontally. Doesn't matter what you do to make your cycle, but you have to be consistent with it. Okay, you can't go like 3 boxes up to 1 and then 1 box down to negative 1. Okay, you can't go 2 boxes out with the first critical point and then the next one's only 1 box further, and then the next one's 3 boxes away, and the next one's 4 boxes away, and back to 2. You know what I mean? Like, you have to have it be nice and accurately graphed. Okay. But let's put a scaling down here, okay? We got to figure out how many radians it takes to complete the cycle, and that's what this is about, see? So period is a standard 2 pi radians if you don't have a horizontal dilation going on, but we do. So I have to multiply by 1/3, there's my scale factor, and that gives me a period of 2 pi over 3. So I know that cycle ends at 2 pi over 3. See, that's what that's about. Okay, the period tells you the number of radians needed to complete the cycle. So from 0 to 2 pi over 3 radians. Okay, 2 pi over 3 radians is needed to complete that whole cosine cycle. Okay, but what is that scaling? Okay, what is it? How many radians is it to get from one critical point to the next critical point? So there's 4 equal intervals, right? Doesn't matter how many boxes we use, but there's 4 equal intervals. So what is that scale? I take 2 pi over 3 and I divide it by 4, which really means take 2 pi over 3 and multiply it by 1/4. Now, right, 2 divides into 4 twice, and I can see pi over 6, so just multiply straight across, is my scale. So this is 1 pi over 6 radians, then it's 2 pi over 6 radians, 3 pi over 6. Now this would make sense because what comes after 3 pi over 6, if we're counting by pi over 6, is 4 pi over 6. See, that's what 4 pi over 6 would reduce to, okay? So but here's the deal with this. I'm not going to have you sketch 2 cycles right here. I'm going to have you sketch within this interval. Okay, I'm going to give you this interval to sketch within. Okay, so I want you to go from negative pi over 3 radians, okay, to pi radians. Okay, so this is an interval to tell you where I want the cycle to start and where I want it to end. That's what that's about, okay? Start and end. Right now I have a cycle, okay, one cycle, clearly. If I start at 0 radians, ends at 2 pi over 3 radians. So if I want to end at pi radians, I have to get another cycle going. But I don't need a full cycle. Let's just see what happens, okay? Let's do one critical point at a time, one reading measure at a time, and see where it takes me. So 2 boxes, okay, after that maximum is going to be the next critical point. So remember, that maximum to start and that maximum to end, that's kind of like where the next cycle starts, right? So coming after a max is a midline. So that's right there. Okay, now is that enough? Okay, is that going to be the right rating measure to end? Well, let's see. So it's 1 pi over 6, 2 pi over 6, 3 pi over 6. Remember, this was 4 pi over 6. So this is 5 pi over 6. Nope, not enough. Okay, I got to get to 6 pi over 6 for that to be pi. So what do I have to do after that max? After the midline from the max, is I got to go down to the minimum. Okay, so 2 boxes later, make sure you keep equal scaling. I'm going to come down to the minimum, and that is going to be 6 pi over 6 or pi radians. So that's good. Now I got to tackle this, okay, negative pi over 3. So I got to extend the cycle that way. So 2 boxes, okay, to get from one critical point to the next. Okay, so what's going to happen when I go from this max, okay, to the left, okay, I'm going to go down to that midline, okay, and that's going to be at negative pi over 6. And then how about the next one? Okay, I'm going to go 2 more boxes down, see, because that's not enough. I don't want to go to negative pi over 6. I want to go to negative pi over 3. So extend that, okay, 2 more boxes further down, further to the left, and that is going to be this minimum, okay, and that is going to be negative 2 pi over 6. Well, what is negative 2 pi over 6? It's negative pi over 3. So now that is what I've got, okay? So that looks terrific, but I'm not done, okay? I did a really good job with the dilation, okay? I have this interval that I've sketched out to, so I'm great with that, okay? But now I got to do this, okay? So the reflection over the x-axis, that basically just takes your maxes and mins and, you know, switches them. Maxes go to mins, mins go to maxes. Your midline points, which are right on your x-axis, they stay right there, okay? So that goes up here, that stays, that goes down, that stays, that goes up to the max, that stays, that goes down to the min, that stays, and that goes up to the max. So I just now connect them. So basically it just takes the graph and it sends it, makes it go upside down, okay? So again, I'm gonna like kind of scribble out the other one, or I could just erase it. Okay, if you want, you could just erase that, or you could use color to make it really stand out, you know, one sketch from the next sketch, and I'm done with that. Now the last thing I got to do is I got to translate. Okay, so this is going to go up 4. So that's why I really made sure I put the x-axis a little lower this time, right? Because I know I eventually would have to go up 4. So if my minimum point is at -1 and I go up 4, well, I got to make sure I have that scaling of 3 there. My midline is going to be at 4, and then my max is going to be at 5, right? So I'm just going to make a nice little dotted line here. Okay, at y equals 4 for my midline. And now I'm just going to move all the points up 4. So this point, I'm just going to go up 4 boxes. So what's really nice about, you know, having your scale on your y-axis be 1 box for every unit is you could just count boxes, but you just want to make sure you go up that number of units, right? Then you've got your midline, which was at 0, right, running the x-axis. Now that's going to be up here. Then the next one I had was the minimum at -1, so that's obviously up 4 boxes to the 3. Then this midline point is up 4 boxes to there. Again, the maximum is up 4 boxes to the value of 5. All right, so let's just look so far. Try to make sure you go through your points. Okay, there we go. And the other thing is, don't be straight about this, okay? I know it's very easy to make it look like, you know, they're just diagonal lines, but this came from a curve, okay? This is a curve. I mean, it came from the unit circle, right? A circle. That's what you were rotating around, okay? Either clockwise or counterclockwise to go, you know, to the positive x or the negative x rating measures, okay? Sorry, positive or negative x-axis, positive or negative rating measures. Like, so it's a curve, okay? There's nothing straight about that, okay? So anyway, just keep going. So 2 more boxes down here, 2 more, 2 more, 2 more, okay? And you don't need to do anything with the radian measure along the x-axis. I mean, that's right there. Let's leave it right there. I mean, that you still have all those radian measures corresponding to all these critical points. Notice how I plotted the points, right? I just moved each point up 4. Okay, so I have max, mid, min, mid, max, mid, min, mid, max again, right? Now, what's really interesting, hopefully you kind of are seeing this too, is by doing all these different transformations, I had what was initially a cosine graph. Now it, like in a way, well, actually, it still is cosine graph, but if I had not had that extra part of the sketch on there, it could even be thought of as a sine graph, right? So these are within each other. Okay, the sine and the cosine cycles, they're all the time like one is resembling the other. So don't be alarmed by thinking that. All right, so hopefully you understand vertical translations. Hopefully this clears up some work with respect to dilations and if needed the reflection and the whole accuracy of the graph and everything with the critical points. So try your best with the homework. Again, gotta be on graph paper. So either you have your own graph paper or you print something from the internet or you make your own gridded paper, but it has to be accurately sketched. Okay, I'm not going to be giving I'm not even going to check off homework if it's not accurately sketched. Okay, it needs to be. All right, hopefully all is well. Talk to you later. Bye.